Hello and welcome back. Today we'll be talking about amount of an ordinary annuity. Okay, so what is an ordinary annuity? An ordinary annuity is, let's say it's when you, let's rephrase. Okay, so an ordinary annuity is when you make payments over a period of time, and the payments are made over regular intervals, and they have interest added onto them. I know it's a little hard to understand, and that's just because the way it's the definition is hard to put into words, right? But I would say the best definition that I could give for an ordinary annuity is an ordinary annuity is when equal payments are made over a period of time, and interest is compounded upon these payments at regular as they are paid in regular intervals. So what this means is that in an ordinary annuity, equal payments are made at regular intervals over a fixed period of time, and compound interest, and these payments are increased by the method of compound interest. So it's hard to understand, but once I get into the formula, it'll be really easy to understand. So let's look at the formula quickly, and that way I'll be able to show you exactly what I mean. So the formula of an ordinary annuity. What is it? It's amount A is equal to payment R, payment at the end of each compounding period, into bracket 1 plus I, interest rate per compounding period, bracket again to the power of n, which is number of compounding periods, minus 1, and all this is on top of I, interest rate per compounding period. Okay, so I'm going to give a quick example, a quick little scenario where that demonstrates ordinary annuity, and that for sure that'll help you to understand exactly what an ordinary annuity is. Okay, so let's say you have $10 right now. Oh, sorry. So just say you have $10 right now. So you have $10, and actually I don't like this color. Let's go with blue. Blue is better. Let's say you have $10, and okay, not $10. Let's say you have money, and you want to invest this money into a bank. So each month, let's say every 3 months. So every 3 months you invest $100. You deposit $100 into this bank, not invest. So every 3 months. You know what? Let's just write. You put $100 per 3 months, and let's say you put this. You continue this for, say, 3 years. So for 3 years you do this, and let's not forget, in an annuity, in an annuity, you have a compound interest onto it. So let's say this bank that you're putting these $100 every 3 months into has a compound interest rate of, let's say, 3%, and it's done every, has a pretty high interest rate. Okay, so that's done every per, let's say, quarterly. So 3%, let's just write quarterly. Okay, so now, I mean, you should understand what we're trying to find now. If you have, okay, so you do this for 3 years. So you put $100 into a bank every 3 months for 3 years, and the compound interest is 3% quarterly. So now what you want to know is how much money you're gonna have at the end of those 3 years in that bank account. So this is exactly what an ordinary annuity is. So if you write the formula down now, you have A is equal to R. You have 1 plus I to the power of n minus 1 on top of I. Okay, so now this is the formula. So now this formula will show you how much money you have after 3 years. How's it going to do that? Well, let's take a look. R, let's go back to our PowerPoint and define these again. So R is what? Amount at the time. Oh, sorry, that's A. R is payment made at the end of each compounding period. So let's go back to this now and look at payment made at the end of each. So your compounding period is quarterly, therefore every 3 months. And after every 3 months, you're dropping $100 into that account. Therefore, your R value must be $100 because that is what you're paying. Now let's go back to this. Next you have 1 plus I. I is what? I is interest rate per compounding period. Now, let's go back and look at what that is. 3% quarterly. Therefore, your interest rate per compounding period, which is quarterly, is 3%. So, you have that value as well. Now you have R and I. Now, last thing, of course, you probably already have caught on now, is N to the power of N. N is what? N is number of compounding periods. So let's go back here and let's look at this, because I want to see if you guys fully understand this. So now you have N. N is three years, right? But it's a little more complicated than just 3 years, because what your compounding periods is not 3 years. Why? Because your money is being compounded quarterly, not yearly. So what do you do to this 3? You multiply it by 4, because it's 4 times per year. However, now you have to account for that in the interest as well. So if you multiply your N value by 4 in order to get amount of compounding periods, you also have to factor that into your I value. So your I value would then be 3 divided by 12 is equal to I, and I is equal to 3 over 12, which is 1 over 4, so 0.2. Oh, sorry, yeah, that seemed a little weird. I was like, 0.25, 25%? What kind of bank account does this person have? Let me get into that. But no, okay, so let's go back now and look at that. I made a quick mistake. It's 3%, so it'd be 0.03 is the right number. There, this makes much more sense. Divided by 4, and that will give me, I'm not even sure. Let's just use a calculator in case anybody's wondering and can't live without knowing what 0.03 divided by 4 is. 0.03 divided by 4, and we get 0.0075. So let's just write that out. 0.0075. Okay, so this is your interest now that you would use, not 0.3. So that's the big we've already learned this in compound interest as well, right? So, I mean, this is just a sorry. This is kind of like a review on compound. This applies to almost all formulas. Like for example, in compound interest, you would have P1 plus I to the power of N. And let's say this is the exact same scenario, except $100 is your principal, not every 3 months. You would have 300 multiplied by 1 plus your I value is 2%, so you would still have 0.03 divided by 4, and that would be to the power of 3 times 4. So, I mean, this is general, but I just wanted to make sure that everyone knew it, so they're on board. All right, let's move on now. So that's pretty much it for compound. Ordinary annuity. Because I mean, if you take a look here now, you can see that you understand the formula. I mean, you have your I, you have your N, you have your R. I mean, it's not much to understand. I mean, if you understand it, you understand it. It's pretty simple. All right, let's go back now and do an example to make sure we understand this. So I'm just going to go ahead and get the example from the PowerPoint so that we may work on said example. Control C that, and Control V, and bring that up here. It's about high enough. Particularly long question. Oh my god, this is incredibly long. There we go. Okay, so now let's take a look at this question. John got a part-time job at Burger King during each of his summer breaks at high school. At the end of each summer, he deposits $1,500 into an account with an interest rate of 4.5% compounded annually. How much money will he have by the time he graduates if he starts depositing the money before grade 9 and makes his last deposit the summer before grade 12? Easy enough. Let's take a look at the key values like always. So first things first, we have at the end of each summer he deposits $1,500. Therefore, the amount of money he's depositing at his regular intervals is $1,500. Therefore, we can just write right now R is equal to $1,500. Next, let's take a look at the interest rate. We look here, it says 4.5% compounded annually. Therefore, our interest rate is simply 4.5%, not divided by anything because it's per year, so there's no need to. And let's, like always, get rid of the percentage Okay, so like always, get rid of the percentages. So 4.5% divided by 100 gives us 0.045. That's the number that we'll be using in our calculations. Okay, moving on. Now, next what we have is time. Okay, so time is pretty simple. Let's see here. He deposits summer before grade 9, so grade 9 counts, and makes his last deposit the summer before grade 12. So what we're going to get for time is um, 4 years. Okay, so the reason I wrote time is equal to 4 years is because I want to make something absolutely clear. Um, n does not equal time. What n equals is, well, actually, I guess you can say in a way it does, but what n truly represents is the number of compounding periods. What that means is that, okay, well, in this case, n does equal time. So in this case, n is equal to 4. This is only because the payments are being compounded annually, so it is per year that you, so it's once per year that your compounding happens. So if it says for 4 years, then your number of compounding periods would also be 4. However, in specific scenarios, you could have it's compounded quarterly, annually, bi-weekly, daily even. So in those cases, your compounding periods would go up. So for example, if it said semi-annually, then you would take your time and you would multiply by 2. Why? Because it's happening twice a year. And since it's happening twice a year, the number of compounding periods are doubled. Simple enough, but I just wanted to make that clear because some people might not have caught on to that right away, right? So I just wanted to make that absolutely clear right in the beginning. Because I once too believed that the n value was time, but I know now that it's not. Okay, so now let's write out, we have all our values that we need. Let's write out our equation. A is equal to R into 1 plus I to the power of n minus 1, all on top of 0. Oh, sorry, let's just write I for now. I bracket close. Okay, so now we have our values. Let's sub them in. It's equal to 1500. We know that. 1 plus 0.045. Oh, and I recently understood this as well. 1 plus 0.045 is simply like, if you have $100 and you say it's increased by 90%. To find that out faster, you can just do 1.9. So that's the same. Oh wait, no, never mind, never mind. That's the conversation for a different day. Let's continue with what we're doing. 0.045 in that's it, right? 0.045, yeah, into 4. Sorry, to the power of 4 minus 1, all on top of 0.045. Okay, so now we have this here, and from here you can pretty much solve the equation. I mean, my calculator allows me to do it in a way that I can just like write these numbers out. But for you guys, since some of you might not have that, I'll actually solve it. So let's say 1 plus 0.045 will give us what? Let's put out our calculator. 1 plus, sorry, 1 plus 0.04. I hate using the calculator on the computer. It's just absolutely terrible. Okay, so that's what I thought it was. 0.45 to the power of 4 minus 1 divided by 0.045, bracket close. I mean, I'm pretty much just wasting time at this point, but I just want to make sure no one gets lost, or I want to make sure everyone understands this concept fully. So now we know that this is to the power of 4. So this is to the power of 4 that, and you get 1.1925. 1.1925. So 1.1925 minus 1 over 0.045. So at this point we have a pretty easy equation. Now actually, it was an easy equation from the beginning. I shouldn't say that. So I can just write 0.1925 divided by 0.045. And for me, I'm just going to do it on the calculator now. If I have, let's just do minus 1, 0.1925 as we assumed. So now let's do 15. Oh, sorry. It's 1500. I could have made a huge difference. Multiplied by, oh no, it doesn't work. This calculator is terrible. Like I said, it's 1500 multiplied by bracket 0.1 925 divided by 0.045, and I can close those brackets off. And for as you can see, it's calculator is not the best. Let me do it on in my hands to make sure, because that's obviously not the right answer. 0.0 oh 0.192 oh wait, what? 0.1925 or 0.045. Give me 1 second. I'm just doing it on my own calculator, as it is much better than this one. 0.1925 on top of 0.045. Close these brackets off. Yeah, I mean, I'm doing it right now on mine, and it's giving me the right answer, which is 6416. Change that to that $0.67. And I mean, that is the correct answer. That's what you should be getting. I mean, the calculator here, let's look at where we might have went wrong. It could be anything. It's not 0.1925. Let's just try quickly. 0.045. Oh, see, look at that. I mean, I understand what it did. It didn't multiply by 1500. So now we multiply that by 1500, and we get 6416. So you see, it's the same answer. It's just this calculator is terrible. I mean, I hate using it. But yeah, so that's that. And let's go back to our PowerPoint and make sure we got the right answer. 6417. And what did we get? 6416.67. Okay, so if you round it off a little more, you'll get around the same. It's pretty much the same thing. And let's move on to our counter example now. Alright, so let's copy this and we paste it. We'll paste it right here. Sorry about that little pause. Let's get back to this. So we're copy pasting this question. So Control C this and bring it here, and let's put that up. Okay. Small question, simple enough. Let's take a look. Mary wants to, let's take a look at the key values. Mary wants to travel to France for the summer. She invests $500 every month into an account that pays 5% interest compounded annually. How much money will she have in 3 years? 3 years. So let's see if we can, how easy this question is. So she invests $500 every month. So that's $500 is definitely our R value, an account that pays 5% interest compounded annually. So annually meaning it's 5% per year. And how much money will she have in 3 years? So we have our key values. R is equal to 500. Oh, let's put dollars as well. Change the shape a little bit. Yeah, I like that better. $500. Next we have 5% compounded annually. So of course I is going to be equal to 5%. Like always, let's get rid of this percentage sign by dividing by 100%. And what we get is 0.05. That's the number we'll be using. And finally, in 3 years, therefore her N is 3 years as it's compounded annually. So now let's write down our formula. A is equal to R. I mean, I would just jump to solving it, but then I don't want you guys saying I forgot something or, made a mistake. Blame it on me. So let's just continue solving. And that is our formula. R1 plus I into N minus 1 over I. Okay, next we have 500. And then we have, oh sorry, I'm already a little slanted, 0.05 to the power of 3 minus 1, all on top of 0.05. And I'm going to solve this on my calculator just simply because I don't want to waste time on the computer calculator, and I just don't like using that calculator anyways. So what do we have? We have 500 into 1 plus 0.05 into 3 minus 1, all on top of 0.05, and then brackets surrounding that, multiplying it by 500. And the answer that we get is, I'll just put a dollar sign there right now, 15, oh, put a 7 for some reason, 1576.25. So 1576 and a quarter. So what you essentially have is $1,576.25. And I didn't do this before, but I just want to tell you right now, you should always have therefore statements. So therefore, as this is the word problem, she will have 1576.25. Excuse my writing. I'm not the best pensmanship, I think is the word. After 3 years. Okay, so now, like I said, this is a counterexample. So of course, like always, I made a mistake, and I'll give you a second for those of you that want to figure it out to see if you can rewind the video. Well, actually, you can just pause the video. So I'm not going to give you any seconds. Let's see if you know, if you found the mistake, good job. And if for those of you that didn't, let's take a look at what the mistake was. Now, like always, the mistake will always be embedded in the question and our interpretation of the question. So, Mary wants to travel to France for the summer. She invests $500 every month. Oh, what was that? Did I just read $500 every month? There we go. We have our mistake. It says here that she invests $500 every month. And we took it as $500 every year. So, because our interest is compounded annually, so we need to find out how much money she put in per year. And to do that, of course, there's how many months in a year? 12. So if you have 500 every month and you have 12 months, you have 500 times 12, which gives you 6,000. So now our real R value is 6,000. I should put dollars before that. $6,000. Okay, so now we can redo the, oh, did I go too far? Let's go back. Oh, where did my equations go? Here, give me 1 second, I can zoom out. There it is. Got you. And now we zoom in. And one more time. Okay, so 5,000 times 12, so our R value is 6,000. Now let's go back and solve this question the correct way. So, what did we have? I'm not going to write the whole equation out. I'm just going to solve the equation because we just simply changed the values. Oh, we can just change them over here too if we use our eraser tool. Erase that. Not working out well, but I don't know how to change the color of the eraser anyway. Oh, there we go. Okay. So if we change the color, we can make it black from